So this is a lecture on the material in section 3.8, implicit differentiation. I did put a couple of videos from recommended videos on YouTube. There's a lot on there, but I put a couple that I thought were kind of reasonable. And the one thing you may, if you did watch the videos or if you looked at any other material on implicit differentiation, it does require good knowledge of the chain rule and also algebra, yes, because we're going to at some point likely be solving an equation. And so, so up to now, we've been talking about, we don't actually say explicit differentiation, but we've been talking about functions where the y is isolated. It's just y equals something like here, like y is, we've seen that in algebra, y is like a parabola, y equals x squared, or y is the dependent variable. So y is typically on the left. And then on the right side of the equal sign, we have some function that that with x as the independent variable, or t is time as the independent variable. But sometimes we have where functions y is not expressed explicitly but implicitly. So like here, here's a circle radius of the radius is 3. Here's another function, x sine y minus y cubed cosine x equals 10. So we say it's in when we don't have y equals, when the y is not isolated on the left side of the equation, or one side of the, typically on the left, we say that y is expressed implicitly. And so, but we still may want to find y, we still want to find the derivative, um, and and so we're actually going to use what's called implicit differentiation, which is really dependent on, you have to, be able to use the chain rule. So let's just look at a good example right here. And let's just look at this example B right here. So we want to take the derivative. So y is the dependent variable, and it's dependent. So we're going to say y is some function of x. And so we want to take the derivative of y with respect to x. So we're going to use the chain rule. So it's 3, we drop the exponent down, 3, and then and subtract 1 from the exponent, 3y squared. And then we take the derivative with respect to x, dy dx. And then, oh, here's a one that's even better. See there, it's x squared y cubed. So we have to use a combination of the product rule and then also of the chain rule. So x squared times the derivative of y cubed, so 3y squared dy dx. And now the derivative of x squared times y cubed. Okay, and so of course, this is actually not necessary, this dx right here. Okay, so and then there's a couple more examples that we see right here. So and so actually, let's take a look at this problem right here. And so this is kind of a, actually, let's look at example 4. That's the one I wanted to look at. Example 4 here. And I like it because it has the trig function in there. And then the trig function, it's sine of 2x plus 3y. I actually have some problems from the homework that I'd like to look at. Okay, so so we have this, so y is defined implicitly. So on the left here, we see x squared and sine of 2x plus 3y, and then minus 4y equals 6. And so we're going to take the derivative of both sides. So of course, the derivative of 6, that's the constant, that's just 0. So taking the derivative of the right side isn't that hard, or that's the easier part. And then let's take the derivative of the left side. So of course, anything that's just x alone, we don't have to worry about necessarily using the chain rule. Okay, so the derivative of x squared, yeah, we get 2x. And now this would be the challenging part right here. This is, or the most challenging part of this problem. We want to take the derivative of sine of the 2x plus 3y. So we're going to use the chain rule. We know the derivative of sine is cosine. So we get cosine of 2x plus 3y. But now we have to take the derivative of that input argument, which is 2x plus 3y. So the derivative of 2x is 2, and the derivative of 3y is 3y prime, or dy dx. And then we subtract off 4 dy dx. Okay, so again, so the derivative of the left side of this equation right here is 2x, cosine of 2x plus 3y, and then 2 plus 3 times y prime minus 4y prime equals 0. Okay, so now this is, okay, so that's step one. Okay, so just taking, taking the derivatives, using the chain rule, maybe we have to use the product rule or something else along the way. And now we want to solve for y prime. So now we have to have good algebra skills. So, hopefully, and so what do we, so we see that we want to solve for y prime. Yes, hopefully we remember all this from our algebra courses. And it'll come back pretty fast if you've forgotten some of it. And so notice how we have a term, we have a y prime term here. We have a y prime term there. We want to isolate y prime. So we get all the terms with y prime on the left side of the equation, all the terms independent, not involving y prime on the right side of the equation. And then you just factor out dy dx and divide, and you get dy dx. Okay, so we get so dy dx is multiplied by 3 cosine 2x plus 3y, and also by -4. Okay, so that's, so on the left side, yeah, we get 3 cosine x, 3 cosine of 2x plus 3y minus 4, yeah, times dy dx. And then on the left side, you have minus 2x. You subtract 2x from each side. You subtract 2 cosine of 2x plus 3y from each side. And then you just divide. And so, yeah, so you get this expression right here. It kind of, yeah, looks like a bit of a mess. Maybe it's a little bit hard to read, but I think we get the idea. So let's just look at what, there's a lot of other problems in here, and I have a few more. But here's one that I think it was actually in that first video that I recommend. This is kind of a classic implicit differentiation problem. And so it's example 7. So you want to sketch the graph of x squared plus y squared equals 25. So that's, the circle of radius 5, center at 0, 0. And so let's first find dy dx. And anyway, what is the slope of the circle at any point x comma y? So again, we use, and then I'm just going to show you a common error. Okay, so yeah, so the derivative of x squared is 2x. The derivative of y squared is 2y dy dx. And now let's just solve, again, just like an equation. We subtract 2x from each side and then divide by 2y. And then so we get dy dx is minus x over y. And okay, so that, okay, so like in the first quadrant, right, we see that the tangent lines would have a negative, doesn't, if we actually just drew, like we see right here, the tangent lines would be negative. Well, that would kind of make sense because x and y are positive in the first quadrant. And the same thing in the third quadrant, x and y both have the same sign. So once again, the tangent lines are negative in the third quadrant. Okay, so now let's just find the slope of 3 comma 4. That's a point on the circle. 3 squared plus 4 squared equals 25. And it turns out the slope is -3/4. And so, okay, so the slope is -3/4. So what is the equation of the tangent line? It's y minus 4 equals -3/4 x minus 3. Yeah, and they kind of, yeah, you can graph it. It should actually just, yeah, so we see that this line here, the tangent line, yeah, it does intersect the point 3 comma 4, and the slope is -3/4. So yeah, and kind of needs your intuition that it would be a downward sloping line, and of course at -3 comma 4, which is, yeah, this line right here, yeah, the slope is positive, right? Because the slope is 3/4. Okay, let me just show you a common error right here. Okay, so this would be when I teach at calculus sometimes, not as much as some of the other teachers. But I see a lot of students forgetting to go dy dx. So this would be an error. I'm going to try to draw on the screen here. So I want to take the derivative of the left side. And what I've seen some students do is go 2x. Let's see, maybe give a little more space here. So some students will go 2x and then go 2y, and then they forget to go times y prime equals 0. So here, that's an error right here, right? So forgetting to actually do the implicit, using the chain rule to get y prime is a really very common error. So why don't we look at some of the homework problems? I've actually put them online. So let's see if I can do this. Okay, so it's another one. So this is problem. It's another. But we're going to actually, yeah, so let's just kind of similar to what we just did. Now this is the we're gonna use implicit differentiation. We have a circle where the center, where the radius is the square root of 20. And then we want to find the slope at 2 comma -4, and then we also, we only have to find the slope. We don't actually have to find the tangent line. Again, we know we just found the slope, right? We found y prime. You just take the derivative of each side, you get 2x plus 2y, y prime equals 0. Solve for y prime. We get y prime is minus x over y, and then at 2 comma -4, right? You just plug in, so x is 2, y is -4, so minus 2 over -4 is 1/2. And so one thing, it's very easy to make algebra errors in here. So like you might forget to, you have a minus and a minus, and you might make that error. Or maybe not, maybe hopefully you won't make the error. Okay, so that we just did a problem like that. Let's look at problem, 10. 10 looks like a fun problem. I kind of like this problem because it has so it's likely there'll be one of these on the quiz and on the test. You want to use implicit differentiation to find dy dx. So we have to use, on the left side, we're going to have to use the chain rule, right? We have to take the derivative of xy, and then to take the derivative of xy, we're going to have to use the product rule. So I wrote right here the derivative of xy. So it's the derivative of x times y plus x plus times the derivative of y, which is y prime. So just preparing that ahead of time. Okay, so let's take the derivative of the left side. The derivative of cosine is minus sine, so we get minus 3 sine of xy. Now we have to take the derivative of the inside, the input to cosine, and so the derivative of x times y. And so we just calculated it. That's y plus xy prime. And the left side, I'm sorry, the right side is the easy. I remember as a student doing these. I always liked it. This part's great. 8x plus 7y. Okay, so the left side is minus 3 sine xy times the expression y plus xy prime, and then the right side is derivative of 8x is just 8. The derivative of 7y is 7y prime. Right, so we have to remember, when you take the derivative of y is not 1, it's y prime. Okay, so now, so we've done the implicit differentiation. I'm circling it right now, but we have to solve for y prime. So the rest is just algebra. Okay, so let's just, everything with y prime will be on the left, and everything not involving y prime will be on the right. And I put I multiplied the terms multiplying the sine function on the left of sine of x. Okay, so on the left side, we have minus 3xy prime times sine of xy. I put that to the left of the sine. And then we subtract off 7y prime from each side. But I'm factoring out that minus sign right there. And on the right side, we have 8, and we're going to add 3y times sine of xy. Okay, so the left side, we have minus the expression 3xy prime times sine of xy plus 7y prime equals 8 plus 3y times sine of xy. Now let's factor out y prime. So you get minus y prime times the expression 3x sine of xy, sine of x times y plus 7 is equal to 8 plus 3y times sine of xy. And just divide both sides by 3x sine xy plus 7, and also divide by the minus sign. And so the answer is there is circled. And so if you look here, students, so this is, you might look at problem 10 and wow, it is hard. Right? First of all, hard is what we don't know. So if you don't, if you're new to this, this will, I think can be challenging. It's definitely easy, not only to make differentiation errors, but to make algebra errors. But if you look at it, it's really not a lot of math. I mean, in terms of the number of lines that we took to solve this. Okay, so let's do the very last problem here. And this one involved a little bit of a trick, and I'll show you. So this is problem number 12, and 2y is equal to the quotient of x plus 6 over y minus 6. To make it a little bit easier, I multiplied each side by y minus 6. So that avoids the use of the quotient rule. And then we could use the product rule. We won't have a y in the denominator, because if you use the quotient rule, you're going to get y minus 6 squared. In the denominator. So to avoid that, that's the one thing that would make number 12 maybe not so. If we actually just took the derivative of each side, it makes it a harder problem. So that's a little trick that I did right there. So that part is not so necessarily obvious, that makes the problem easier. But multiply both sides by y minus 6. And then we just, and the left side now is kind of now the right side is our friend, x plus 6. And so that part, taking the derivative of x plus 6, so that's the easier part of this problem. The left side, just expand, and we get 2y squared minus 12y. Oh, I left out the equals x plus 6. Now take the derivative of the left side. And so it's 4y, right? We drop down the exponents. We get 2 times 2. We get 4y. And then don't forget to do the chain rule. 4y times y prime minus 12y prime equals 1. And we're going to isolate. Now it's just, okay, so we've done the implicit differentiation. We're done with the calculus part of the problem. Now let's just, now it's the algebra part of the problem. Solve for y prime. Factor out, factor out 4 y prime from each term. So we get 4y prime times y minus 3, and then we'll divide each side by 1 over 4y minus 3, or 1, or you can also write it out, I think, as 1 is. Oh, that's my cat, and I'm not doing anything to her. She just wants me to feed her or she just wants me to stop talking to the computer. Okay, so that's another way of writing it. So yeah, so you solve for y prime. I think either this is a decent solution, the one I wrote, 1/4 times y minus 3, or 1 over 4y minus 12. But once again, here's a trick right here, multiplying each side by y minus 6. But once you do that, there's really aren't a lot of steps to it. And once again, students, the common error, what would what I've seen when I've graded these a lot in the past, would be right here. The error would be forgetting to use the chain rule in y squared. So I see this a lot. 2y, minus 12y prime is equal to 1. But that's incorrect. Right, so we're missing the 2y should actually have the 2y should actually have a factor of y prime. So just remember, when you have like y squared, just remember you have to apply the chain rule. Okay, so if you apply the chain rule correctly and do the algebra correctly, you'll likely get all these problems correct. And I'm going to see here, stop the recording.